Hello and welcome to this video on Listwise Deletion in Mplus. My name is Geiser. I'm an instructor and statistical consultant with QuantFish, and on this channel I present weekly statistics tutorials. I usually talk about multivariate statistical methods including structural equation modeling, factor analysis, and latent class analysis. If this is something that interests you, then please subscribe to this channel. Also, don't forget to check out the description for additional resources, including a link to our newsletter as well as free courses that I teach for QuantFish. In this video, I want to talk about how you can obtain listwise deletion with missing data in the Mplus software, and also what the Mplus defaults are for missing data analysis and whether you should really actually use listwise deletion and or under which conditions you might want to do this or not. So let's take a look at an Mplus example for a regression model in which I have missing data. And so here the first thing that I want to show you is an Mplus output file where I went with the Mplus defaults for missing data handling, and we'll take a look at what we get when we use the Mplus defaults. You can see here that my data set has 5 variables: x1, y, z, x2, and x3. I'm only using x1 and x2 and y here for my regression example. And you can see we have missing data which are coded as 999 for all variables, meaning whenever Mplus encounters the value of 999 in the data set called data.dat, it will treat it as a missing score. The model is a simple bivariate it's a multiple regression model with 2 predictor variables, x1 and x2. So it's a 2 predictor model. It's a linear regression of continuous variable y on 2 predictor variables, x1 and x2. And I included the x1 and x2 variances here in the model, which is useful to do in Mplus so that even cases with missing data on x variables will be included in the analysis when we use the Mplus default here, where we will see that the Mplus default actually includes cases with missing data in the analysis. Let's scroll down and let's take a look at what we get in the output file. One last thing is that in the output command I specified patterns, which gives us the missing data pattern information, which shows us then how many cases have missing data and what their pattern of missingness looks like. The sample size is 300 observations, and that includes cases with missing data if they have at least data on one variable, so either y or x1 or x2. As long as they have one value, they will be counted in the analysis. Only cases that have no values at all for these 3 variables would be excluded at this point. When we scroll down, we can see under summary of data information about the missing data patterns. And so the first thing that Mplus here prints is a diagram or a table that shows us the different missing data patterns, where X means data is present or not missing. So this means that the first pattern here in this table, so the first column, indicates a complete data pattern where you have an X for Y, you have an X for X1, and you have an X for X2, indicating that those are complete. This is a complete data pattern. So pattern number 1 is a complete data pattern, and beneath this table you can see the missing data pattern frequencies. And for pattern number 1, we see that the frequency of this pattern was 145 cases. So about half of our sample, 300, 145 is a little less than half of that sample of 300, has complete data. All the rest has some kind of missing data pattern, which indicates that you lose a lot of data if you used listwise deletion, because those remaining 155 cases, they would all be deleted if you used listwise deletion. So you can already notice that I'm not a big fan of listwise deletion, even though this video is about how to get listwise deletion in Mplus, and I'll show you that. Pattern number 2 is one where the individuals were missing the X1 score. You can see there's a hole here for X1, and so these individuals have data only for Y and for X2, and so this pattern number 2 was observed for 36 individuals. Pattern number 3, with pattern number 3 we see missing data for the dependent variable Y, and that was observed for 28 cases. Pattern number 4 is one where we have data only for X2, and that pattern was seen in 91 cases, so quite a few. Now again, notice that pattern number 2, pattern number 3, and pattern number 4 would be excluded in a listwise deletion analysis, so you'd lose a lot of cases. Now, with this default in Mplus, we're actually including all those cases, even the ones that showed pattern number 4, even the ones that have data only for X2 are included in our model here, because Mplus uses full information maximum likelihood estimation with missing data as the default. So missing cases will be included, and Mplus will simply extract all the information that is present, even from partial data cases. Those will still be included in the estimation of the regression parameters. And so when you scroll down, the next thing that we see is the covariance coverage, which is calculated based on the missing data pattern frequency. So this shows us for which variances and covariances we have how much data. You can see that for the covariance of X2 with itself, we have 100% of cases. So meaning this is the variance proportion. So say for X2, because this is about the covariance of X2 with itself, which is equal to the variance. And so that variance could be calculated based on all cases, because there was not one pattern where we had missing on X2. You can see that again when you go up. All 4 missing data patterns that were observed included data for X2. So there was nobody who was missing a score on X2, and so as a consequence we have 100% coverage for that variance for X2, because it does not require any of the other variables. We can calculate the variance of X2 solely by looking at X2. We don't need to look at X1 or Y, and therefore here we have 100% coverage. The other coverage looks worse, obviously, because there is all patterns include missingness on Y or X1, and so therefore for the variances of Y, the variance of Y, the variance of X1, we have less than 100% coverage, and then also for the covariances between all variables, we have less than 100% coverage, because X1 and X and Y were not observed for everybody. So the lowest value here is 0.483, meaning only 48.3% of cases provided information on the covariance between Y and X1, because there were many cases that were missing data on either Y or X1 or both. Again, by looking at the patterns, we can see that. So pattern number 2 was missing data on X1, pattern number 3 was missing data on Y, and pattern number 4 was missing data on both Y and X1. And so as a consequence, this covariance has the least coverage. So this is there's the least amount of information available for that particular covariance. Now, that's not necessarily a bad thing or not necessarily problematic. 48% or even less could be enough coverage to use the model. And obviously with listwise deletion, you would have this low coverage and actually less coverage than that for all those statistics. So here we're using all the information from the data, so we have a higher coverage than what we would have if we used listwise deletion. The other coverage values are a little bit higher, 60.3%, 57.7% for those remaining statistics. Now, of importance, this isn't the covariance matrix. This is the covariance coverage matrix, which means those are proportions that show us what proportion of cases provided information for those variances in the diagonal and the covariances off diagonal. The actual estimated covariance matrix appears below under sample statistics. So when we go to the estimated sample statistics, we get the means of the variables first and then the covariances. And that's the actual covariance matrix that was estimated by Mplus using full information maximum likelihood estimation with missing data, and is therefore taking advantage of all available data points, so even the ones that have some missing data. Full information maximum likelihood allows us to include all available data, which is convenient, and it's based on the assumption of missing at random data, which is a less restrictive assumption than missing completely at random data, which is implied by listwise deletion. So listwise deletion, for it to be unbiased, it actually requires missing completely at random data, whereas full information maximum likelihood estimation only requires the weaker assumption of missing at random data. Missing at random data essentially means you have the information about why the scores are missing in your data, either because this information is part of your variables or is included in those variables, or because you add auxiliary variables to your model that account for missingness. And I have another video on this channel, and in fact a whole playlist, in which I show how you can add auxiliary variables to a model like this in Mplus. It's very convenient. It's a single command that you add, and it is very, very easy to do. So for now, notice that this uses all available data. It makes less restrictive assumptions than listwise deletion, and we don't even see in the output file that something has been addressed, so to say, that there has been a missing data procedure that has been implemented here, because we get all our usual statistics as if we had complete data, the means, covariances, and the estimated correlations. Notice that these sample statistics will obviously differ from what you would get, for example, in SPSS using listwise or pairwise deletion, where those statistics would look different, most definitely, because they are based on fewer cases, different cases, and a different handling of missingness. We get the univariate sample statistics as well, and then our regression parameters at the bottom, the regression slope coefficients under on with tests of significance and p-values, and we get the correlation between the exogenous x variables. Here in this case, in the unstandardized solution, this is the covariance. In the standardized solution, this would correspond to a correlation. So this is what we usually get in Mplus, including missing data. Now, this video really is about listwise deletion, and so let's go back to our syntax and let's take a look at how you would actually get listwise deletion and what happens in that case. So let's add a subcommand here to our data command that is called listwise. And so if we turn listwise to on by stating listwise equals on, then Mplus will turn off full information maximum likelihood estimation with missing data, and it will delete all cases that have missing scores on one of the three variables or more. So even if somebody has data on y and x1 but not on x2, for example, then they would be kicked out. So let's take a look at what happens when we turn listwise to on, overriding the Mplus default of full information maximum likelihood, and then run our model again. Now, the first thing that we can see is that Mplus prints a warning stating that the patterns option in the output command is not available when listwise equals on. The request for patterns is ignored. So this means Mplus then does not give you the missing data pattern information if you turn listwise to on, because then there is no missing data. All the missing data has been eliminated, so to say, and then Mplus will not give you those patterns. So this doesn't have any consequences for the analysis, but it's good to know that if you wanted to take a look at the patterns, then you can only do this when listwise is off, which is the default. Scrolling down, we see that we have a dramatic loss in the number of observations. So now we have only 145 observations. This is what you would get in a lot of other statistics programs by default, where, for example, SPSS would delete cases either listwise or pairwise, and then you end up with a greatly reduced sample size, which has potentially bad consequences. So we are left with obviously the 145 complete cases that we saw previously. 155 cases were deleted because they had missing data on either Y, X1, or both. And so now it's a listwise analysis, and we get the same statistics as before. However, we have to remember that now we are at great risk for bias, introducing bias into our regression analysis, because this analysis with listwise deletion assumes that the complete cases are a simple random sample of all the cases, and that there is no systematic dropout of whatever kind, so say missingness is completely unrelated to our data, that it's completely random. Missing completely at random means it has nothing to do with Y, X1, or X2, that people dropped out or didn't respond or something like that. And that's a very restrictive assumption. If this assumption is not met, then there may be bias in our estimation of the regression coefficients or other parameters, and so this is something that we have to remember. Another problem that we're potentially facing is that we are losing statistical power. We have reduced our sample size by more than half, which obviously comes with a dramatic reduction in statistical power, and this could mean that certain results that should be detected, certain null hypotheses that should be rejected because they are false, may not be rejected because of insufficient statistical power. So that's another problem. So both bias may be introduced by listwise deletion, and also statistical power may be greatly reduced by cutting the sample in half, and actually cutting it more than that by reducing it from 300 to 145. So in summary, this is really not a good idea. And there's a good reason why Mplus uses full information maximum likelihood estimation by default for procedures such as regression, path analysis, structural equation modeling, confirmatory factor analysis, and so on. And so that has a really good reason behind it, because Mplus knows that this is a less restrictive procedure. It rests on less restrictive assumptions than listwise deletion. So are there ever situations where you would use listwise deletion? Obviously, when you have a huge sample and there are only a few missing cases, and there's good reason to believe that the data are missing completely at random, then it may not make a difference, which is still not a good argument really to use listwise deletion. But in that case, it may not matter, and there may be some reasons, some technical reasons why you may prefer to use complete cases. Also, one reason could be if you wanted to compare the sample statistics across Mplus and SPSS to make sure your data import worked well in Mplus and there was no error in importing the data into Mplus, then that could be a reason for a preliminary analysis to use listwise deletion, so that you can directly compare the sample means, sample covariances, sample correlations between the programs, just to ensure that your data import worked fine. But those are really the only two reasons that I could think of that you would use listwise deletion. If you have any ideas that I missed, please leave them in the comment and let me know what reasons there could be to use listwise deletion. I really can't think of any. I typically use and recommend full information maximum likelihood estimation or multiple imputation. You can also find videos on how to do that in Mplus here on this channel, so check those out as well. And those are the two that are state of the art for missing data handling: full information maximum likelihood, which is very convenient, and multiple imputation, which is also easy to do in Mplus. I hope you found this video useful to learn more about missing data analysis in Mplus. If you did, then please Subscribe to this channel, hit the like button, and don't forget to check out the description for additional resources, and I'll see you next time.